Variables and data types. Variables. Variable is a container for storing data in memory location. A variable is a name given to a storage area that our programs can manipulate. A variable declaration provides assurance to the compiler that there exists a variable with a given type and name so that the compiler can proceed for further compilation without requiring the complete detail about the variable. A variable definition tells the compiler where and how much storage to create for the variable. A variable definition specifies a data type. A variable name must begin with a letter, AZ or AZ, or an underscore symbol, character. A variable name cannot start with a number 0 to 9. A variable name can only contain alphanumeric characters, AZ, 0 to 9, and underscores. It cannot contain special characters or spaces. Variable names are case-sensitive. For example, name. Name and name are three different variables. To create a variable, specify the type and assign it a value. To declare more than one variable of the same type, use a comma-separated list. You can also assign the same value to multiple variables of the same type. You can output values /print text with the serial.print or serial.println functions. If you assign a new value to an existing variable, it overwrites the previous value. Variables that are created outside of a function are known as global variables. Global variables can be used inside or outside of a function. Data types. Variables can store data of different types that we can use to perform different operations. A variable in C++ must be a specified data type. Data types, classification. Primitive data types. These are the basic built-in data types that are directly supported by the language, such as integer, floating point, character, and Boolean data types. Void types. The data type has no value or operator, and it does not provide a result to its caller. But void comes under primitive data types. User-defined data types. It is mainly used to assign names to integral constants, which make a program easy to read and maintain. Derived types. The data types that are derived from the primitive or built-in data types are referred to as derived data types. Boolean. Bool represents logical values, either true or false. Byte stores small and signed integers from 0 to 255. Short stores smaller signed integers, typically from -32,768 to 32767. Int stores signed integers, with the range varying depending on the microcontroller architecture. Unsigned int stores larger and signed integers than int. Word stores unsigned integers, often used in hardware-specific contexts. Long stores larger signed integers. Unsigned long stores even larger and signed integers. Float stores floating point numbers with less precision than double. Double stores floating point numbers with high precision. Size_t stores the size of other data types in bytes, which can vary depending on the platform. Understanding these data types is crucial for efficient memory usage and writing accurate code in Arduino and microcontroller programming. Char is a data type that stores a single character, represented by a numerical value, often using the ASCII standard. Unsigned char is a variation that stores only positive values. Array is a collection of elements of the same data type, accessed using an index starting from 0. Arrays can be declared with a fixed size or dynamically resized. When working with character arrays, char arrays, remember to include an extra space for the null terminator, \0, to properly store strings. These data types are fundamental for handling text, storing collections of data, and working with various data structures. String is a data type used to store text. In Arduino, there are two ways to work with strings. Character arrays. A string can be represented as an array of characters, char, terminated by a null character, \0. This is a more traditional approach. String class. Arduino provides a built-in string class. This class offers methods for manipulating strings, such as concatenation, comparison, and conversion to other data types. Derived types. Array. Array is a data structure that stores a fixed number of elements of the same type. Pointer. Pointer is a data type that stores the address of another variable. Structure. Structure is a data structure that stores a group of related variables of different types. Union. Union is a data structure that stores a group of related variables of the same type. Function. Function is a block of code that can be called from other parts of the program. Pointers. Memory address. When a variable is created, a memory address is assigned to the variable. When we assign a value to the variable, it is stored in this memory address. To access it, use the reference operator and the result represents where the variable is stored. Pointer. A pointer is a variable that stores the memory address of another variable as its value. A pointer variable points to a data type, like int, of the same type, and is created with the asterisk operator. The address of the variable you are working with is assigned to the pointer. Dereference. We use the pointer variable to get the memory address of a variable, used together with the and reference operator. However, you can also get the value of the variable the pointer points to by using the asterisk operator, the dereference operator.